Hello guys, today I'm gonna explain about errors in measurements, right? First, you should know what is an error. Suppose, let us in our daily life, it is very closely related. Let's say uh, uh, you have fixed a timetable for you, and you thought to complete some subject in 1 hour. You assumed that it will complete in 1 hour, but it took you about 2 hours. That means here 1 hour error. According to your assumption, according to your assumption, the error came out to be 1 hour. So uh, it is very closely related to our daily life. To clearly explain about it, first you should know true value or mean value, which means I told you now just now I told you that assume that you will take 1 hour to complete that subject. That is the true value or mean value, because that is the thing you assume, which is actually the correct one. It is not more relevant example. Actually, I'll try to say most relevant. Suppose, let's you are doing some activity and you observe that to do that activity it took 2 seconds first time, and after you tried it second time, it took 2.1 seconds, and you tried third time, it took 2 seconds, and you tried again fourth time, 2.3 seconds. The true value or mean value is some, let's say some physical quantity is measured n times. Here you measured it 4 times. This activity is done 4 times, right? If some physical quantity is measured n times, then these measured values be a1, let's say this is a2, a3, a4, right? And so on. Let's say n number of times. If you measured a physical quantity n times, then these measured values be a1, a2, a3, a4, and so on an. Then true or mean value is defined as, wait a second, a minute. Then this true value or mean value is defined as arithmetic mean of these values. Arithmetic mean of all the values. That is, you thought that 1 a1 plus a2, we assume that, and so on, plus an upon n. And how many times did you measure them? I hope you understand. Once again I repeat this: if a physical quantity is measured n times, then let those measured values be a1, a2, a3, and so on an. Then this arithmetic mean of all these n number of measured values is called mean value or true value. This is the definition of true value. Let's we just now talk about we just now talked about some example, right? Let's say you took 2 seconds for first time and 2.1. Let's make it smaller. So 1 minute. Let's say 2 seconds for first time, 2.1, 2 seconds, again 2.3 seconds. We took like this, right? Let's say this as a1, a2, a3, a4, right? So this true value of these values comes out to be, true value or mean value comes out to be, here 4 number of observations are there, so sum of all these observations, that is 2 plus 2.1 plus 2 plus 2.3 upon how many number of times you measure this physical quantity, which is n number of times, which is here comes out to be 4, right? So if we add this, 2 4 is 8 plus 0.4, 8.4 by 4, which results you in 2.1 second. So this is the true value. This is the value that is exactly which need to be obtained. But what is error? Error should be defined now, right? Yes. Now, what is error is, first you took 2 seconds, 2.1 to 2.3, right? Then here error comes out to be, actually it is defined as absolute error. Absolute error comes out to be, we thought that a1, a2, a3, a4. Absolute error of first term a1, that is first time we measured now. Then what is the error that we obtained? It was given by true value minus this measured value, obtained value. That is, true value came out to be 2.1 seconds, right? 2.1 minus this much. This time we, in the first time we got about 2 times. Then 2.1 minus 2 results as in 0.1, right? The absolute error of first term comes out to be 0.1 seconds. So this is the error of absolute error of first term. The second term's absolute error comes out to be 0, right? Because the true value and mean value came out to be 2.1. And this third value comes out to be same 0.1 seconds, and fourth value comes out to be, let's write here, it comes out to be 0.2. The difference, not like this one, the difference between true value and the obtained value, and that is measured value, is error. Here 0.2, here 0.1, here 0, here 0.1, right? So these are the errors that we obtained, right? Yes, here the errors results as in, here 0.2 seconds, 0 seconds, sorry, minus 0.2, because the difference is minus 0.2. And here it results in 0.1, here 0, here 0.1. This is the errors that we obtained, right? So these are all absolute errors. Now you need to know other concept in order to solve these errors. Let me explain. What are the errors we obtained? 0.1, 0, 0.1, minus 0.2. So these are the errors obtained. So now we should learn mean absolute error, which means, yeah, mean absolute error, right? Which means the mean of all these absolute errors. It was given by, suppose this is a1, a2, a3, a4, sorry, delta a4, delta a3, delta a2, delta a1, right? We found out these are the errors between the measured values and the absolute value, and that is true value or mean value, which is known as absolute errors. These absolute errors we found out, that is delta a1, delta a2, delta a3, delta a4, and so on, delta an errors will be there if we measured it a number of times. So now what is mean absolute error is, mean absolute error is mod of delta a1 plus mod of delta a2 plus, and so on, how many times. Here we mod of delta a3 plus mod of delta a4 by n, which results is here in 4. So now uh, the absolute error comes out to be, mean of absolute error comes out to be mod of 0.1 plus mod of 0 plus mod of 0.1 plus mod of minus 0.2 upon 4, which results as in 0.4. 0.2 plus 0.2, 0.4 upon 4, which results in 0.1. That means the mean of absolute error results in 0.1, and the true value or mean value came out to be 2.1 seconds. Right? Now this time period exists in some period which can be calculated. I'll show you clearly. Wait. Now it was given by Tm plus or minus delta T, which results as 2.1 plus or minus delta T is 0.1. Right? It results as in, actually this is the way we represent our time period. So if we subtract this, the minimum value comes out to be 2. So if we add this, it comes out to be 2.2. So this is the way we represent this. This is what we obtained. Okay. So this is the time period we found. It may be in that time period. So now we are learning another concept, which is relative error or fractional error. So relative error or fractional error is defined as mean absolute error upon mean value, which means delta A bar upon AM, which is uh, the mean of all absolute errors, right? We found out some absolute errors. What? 0.1, 0, 0.1, 0. Minus 0.2, and we found out mean of all those, which resulted in 0.1 second, I think, and our true value or mean value came out to be 2.1. So this ratio is defined as relative error or fractional error. So it is 0.1, and it came us to be 2.1, which is 1 by 21, to write it simply. And the fifth one is percentage error. In many questions in JEE mains especially, we will be asked to find out the percentage error. In order to do that, percentage is error. Percentage error is defined as delta A bar upon mean value into 100%, which is here 1 by 21. This value came out to be 1 by 21. This is the relative error or fractional error we discussed right now. Yes, this is relative error or fractional error into 100%, which came out to be 1 by 21 into 100%, which is approximately equal to 5%. This error, yes. This is what the basics of error. Let us discuss problems of error in the next video, which I'll be uploading in 2 minutes. Okay. So let's recap this session. There are totally 5 types. 5 things you should learn in order to do these error calculations. That is error in these errors in measurements. Right? Let's recap those all. The first one comes out to be finding out true value or mean value. If you take a physical quantity which is measured n number of times, let those measurements be A1, A2, A3 and so on An, then the true value or mean value is defined as the arithmetic mean of all those values. Yes, this true value is the value that should be obtained, which is correct value according to our prediction. So after true value, you learned about absolute error, right? What is absolute error? The absolute the absolute error between absolute error can be perfectly defined as the error that resulted as between the true value or mean value and the measured value, that is given by delta a1. Let's say that is am, the difference between mean a true value or mean value and the measured value. This is called an absolute error. And for each measured value, it has its own absolute error. Delta a2 has its own error, absolute error. So in this way we found out absolute errors, right? And after learning absolute errors, we found out mean of absolute errors. So that means what error is occurring frequently, which that means to say it perfectly, mean absolute error, which is the error that is occurring every time approximately equally uniformly distributed, likewise. Okay, in the fourth thing we learned is relative error or fractional error. Relative or fractional error. Yes, relative or fractional error is nothing but delta a bar by am, which is mean of absolute error. This one by mean value or true value. This one, mean value or true value. 3 by 1. See, let's say this one as 3, this one. 3 by 1 is defined as relative or fractional error. And fifth one, the last one that we learned now is percentage error. Percentage error is nothing but this relative or fractional error into 100%. This is the percentage error which should be required to do problems. Okay, these are the basics required for errors.